Back in 2008, a paper from the mysterious Satoshi Nakamoto quietly dropped a radical new idea, a purely peer-to-peer version of electronic cash. Today we're going to break down that original 9-page document that kicked off a revolution. Let's dive in and see the blueprint. So, to really get what makes this paper so special, you first have to understand the huge problem it was trying to solve. I mean, think about it. When you hand someone a $5 bill, that's it. The transaction is over. But online, it is a totally different story. And right there, in the introduction, the paper just lays it out. This is the core issue. Every single time you buy something online, you're not just dealing with the seller. You're always relying on a bank or a credit card company to be the middleman, to be that trusted third party. This is what the paper calls the inherent weaknesses of the trust-based model. See, with physical cash, it's simple. It's direct, it's final, but online payments, they're mediated and, this is crucial, they're reversible. But that reversal, that needs someone to play referee and handle disputes, and that adds all this cost and complexity to literally every single thing you buy. Okay, so the paper's goal is to build something totally new, a system that ditches trust and instead uses something called cryptographic proof. It's about finding a way to get that finality of a cash payment, but in a digital world, without needing a bank sitting in the middle. All right, so how do you even start to build something like this? Well, the first piece of the puzzle is to completely rethink what a digital coin even is. The paper defines an electronic coin as basically a record of its own history. It's kind of like a title for a car, but digital. Each owner signs it over to the next, and that chain of signatures is the absolute proof of who owns it right now. And the way it works is actually pretty elegant. You use your secret private key to digitally sign a message that says, hey, I'm giving this coin to this person. That signature gets added to the coin's public history, and bam, anyone can check and see that the transfer is totally legit. Okay, but this brings up the absolute biggest hurdle, right? The billion-dollar question for any digital money, the double spending problem. What's to stop me from taking that same digital coin and just sending it to two different people at the same time? And the solution the paper proposes is, honestly, radical. Forget a central bank with a secret ledger. Instead, we need a public ledger. Every single transaction is announced to everybody, and the entire network has to agree on one single shared history of what happened and in what order. Right, but how in the world do you get a whole network of strangers all over the world to agree on anything? Well, this is where the paper's most famous and maybe most brilliant innovation comes into play. It's called proof of work. The best way to think about it is like a super difficult computational lottery. It takes a ton of computer power, we're talking CPU time, electricity, to find a winning number. But, and this is the key part, once you find it, it's incredibly easy for everyone else to look at your number and go, yep, that's the one. And it's this work that basically locks down the public ledger. So here's how it all comes together. First, all the new transactions get bundled together into what's called a block. Then, all the computers on the network, the nodes, they all race to solve that lottery-like puzzle for that block. The first one to crack it wins, and they get to broadcast their solved block to everyone else. And then, that new block gets cryptographically chained to the one right before it. And there you have it. That's a blockchain. And this is what makes the whole thing so incredibly secure, because every block is chained to the one before it. If you wanted to go back and change something, you'd have to redo all that expensive lottery work, not just for that one block, but for every single block that came after it. The history essentially gets frozen, set in stone by all that computational effort. So how does the network stay on the same page? Simple. The longest chain, the one that has the most proof of work, the most raw computing power poured into it, is accepted by everyone as the one true history. It's not a CEO making a decision, it's the majority of computing power that calls the shots. Okay, so we've got the pieces, right? A chain of ownership and a way for the network to agree on a single history. But that leaves one big question. Why would anyone even bother to do this? Why would they run these computers and spend all that electricity? This is where the paper introduces a really powerful incentive. The node that solves the puzzle and adds the new block gets a reward. Brand new coins. The paper itself compares it to gold miners spending resources to literally pull new gold out of the ground. And this incentive, it's the engine that drives the entire system. And honestly, this is the really revolutionary idea here. It solves this massive computer science problem not with fancier code, but with simple, raw economic self-interest. It's how new coins get created, it pays for the network's security, and, this is the most clever part, It makes it way more profitable for you to be an honest player and earn those rewards than to try and attack the system. Okay, last piece of the puzzle, security. Let's say you're a bad guy. How hard is it really to go back and reverse a transaction? Well, the paper actually does the math. And what the calculations show is pretty amazing. Let's say an attacker has a significant 10% of the entire network's power. Well, after just one new block gets added on top of your transaction, their chance of successfully reversing it is already down to about 20%. Wait for 3 blocks and it drops to just over 1%. And after 5 blocks, their chance of success is less than a tenth of 1%. It becomes practically impossible, really, really fast. And that brings us right to the paper's powerful conclusion. This one sentence sums up the entire breakthrough. We have proposed a system for electronic transactions without relying on trust. It's not about trusting people, it's about trusting the math and the incentives. And what you end up with is a system with these just incredible properties. It's tough, it's simple, nodes can work together without a lot of coordination. People can leave the network and come back whenever they want. Your identity is protected because you're just a public key, and the rules are enforced by everybody through this consensus of computing power. So this white paper didn't just give us a blueprint for peer-to-peer electronic cash. It gave us a whole new way for a group of people to agree on a shared truth without needing a boss or a middleman. And it leaves us with this huge, fascinating question. If you can redesign money this way, what else could you build?